Salam Sejahtera Doctor. My name is Feng Yao with match number 289851. Today, I'm here to present the assignment 2 done by my group, which has the topic of Object-Oriented Programming Language. Here is my group member who are Hashini, Chongpalun, me, Feng Yao, and Fasiatu Amira. This object-oriented programming project focuses on drawing shapes. This project demonstrates the fundamental of OOP principles, which are modularity, encapsulation, abstraction, inheritance, and polymorphism. OOP emphasizes the code organization and showcases how this principle fosters a maintainable and reusable code base. This project was aimed to achieve the modularity via 8 distinct classes, for example, canvas and rectangle class with single responsibilities. Next is the implementation of the OOP concepts, which are the encapsulations and abstraction for clear interfaces and generic interactions. The third objective is utilizing the inheritance for code reuse and hierarchy among the shapes and leverage the polymorphism through the drawable interface for the flexible shape handling. The last objective should be the design for the scalability, maintainability, and the easy feature additions. This project covers up the modular design adhering to the single responsibility principle, which enables the extensibility for new features. The encapsulation and abstraction simplify the maintenance, while inheritance and polymorphism enhance flexibility. The application stands poised for seamless interaction for new shapes, tools, and features without compromising its structural design. The system development involved the class design and implementations. First, the canvas class managed the drawing area, housing shapes, and providing methods for manipulation. Next, the two-panel class in charge for the user interactions, adhering to the single responsibility principle for the modularity and clarity. For the shape class is an abstract base. It defines the common properties and methods. The rectangle and circle inherit tailoring to the specific shapes. Next, this slide talks about the encapsulation and abstraction concept. The encapsulation ensures each class maintains a well-defined boundary for data and operations. For example, the circle class encapsulates the radius privately, exposing the control access through the methods. For abstraction in shape class, it provides a template for the general interactions, shielding users from specific shape details. For the inheritance concept, the abstract shape class establishes the shared attributes and behaviors. The derived classes, which are the rectangle and circle, inherit from shape. It can reduce the redundancy and enabling the easy addition of new shapes. While the method overriding ensures the consistent interface across shapes, aligning with Liskov substitution principle. While the polymorphism involves the interface, the polymorphism allows the canvas class to interact uniformly with diverse shapes. The drawable interface sets a standard contract for drawable objects, enhancing the flexibility and maintainability. The unified draw method in shape class exemplifies the polymorphism, simplifying the integration of new shapes. This is the starting point of the program code. This is the public class concept paradigm. This involves the line of creating a JFrame object. The next is the encapsulation of using methods to manipulate the properties. And then is the setting size using the encapsulations. Next is creating a canvas object, which is a class implementation. Then is a composition using the one class without another. Then the frame.set layout is using the border layout, which also encapsulations. And then the adding the two panel to the frame involves encapsulation also. And then the rest of it also involve the same concept, which are adding the canvas to the frame and then making the frame visible. So the class design and implementation. This class demonstrates the setup and configuration of a Java Swing application, integrating the various components. For the encapsulation and abstraction concept, this is done by creating a JFrame and setting its properties, It shows the encapsulations. However, abstraction is not significantly demonstrated in this class. For the inheritance concept, there's nothing here, and it also doesn't show the polymorphism and the interfaces. Next, this is the public class canvas which extends the JPanel. Overall, for the class design and implementation, it implements a custom drawing canvas managing the shapes and drawing operations. For the encapsulation and abstraction concepts, it encapsulates the shape data and drawing behavior. This code also demonstrates the abstraction by managing the complex drawing operations internal, providing a simple interface to other classes. For inheritance, it inherits from the JPanel and extending its functionalities. And then it also demonstrates the polymorphism concept by overwriting the pen component method from the JPanel. The interfaces are indirectly used through the mouse listeners. For the shape and the rectangle classes, they possess the almost similar properties. For the class design and implementations, it is a specific implementation for the circle shapes and the rectangle shapes respectively. They encapsulates the shape-specific properties, radius for the circle class, and the dimensions for the rectangle class, and abstracts the drawing logic specific to each shape. They also inherit from the shape class, showcasing the reusability and extension of properties and methods. And then both of these class also demonstrates the polymorphism by overwriting the draw method from the shape class. The drawable interface implement heavily the polymorphism and interface concept. Obviously, this is not a class, but is an interface that defines a contract for drawable objects. This is a pure example of using interface to enforce the polymorphism properties. This could represent abstraction at its core as it abstracts the drawing functionality. For the inheritance concepts, the interfaces don't support inheritance in the traditional sense, but it allows the classes to inherit the abstract methods. Next is the abstract class shapes, which implements the drawable interface. It defines a generic blueprint for the shapes. It encapsulates the common properties like coordinates and colors, and abstracts the drawing behavior to be implemented by the subclasses. It also serves as a base class for specific shapes to inherit from. It also implements the drawable interface by ensuring all shapes have a common method to draw themselves. For the enum shape color class, this defines a color constant for the shapes. This class also implements the abstraction properties, which provides a set of predefined color constants, abstracting the need to know exact color values. For the inheritance concept, the enums in Java are special types of classes but do not demonstrate the traditional inheritance in this context, while this class doesn't involve any polymorphism and interface. Next is the public class shape factory. This class implements the factory design pattern for the shape creations. This class encapsulates the creation logic of shapes by providing a simple interface for the shape creations. This class doesn't involve any inheritance concept, but it demonstrates the polymorphism through the return of different shape types based on the input parameters. Next, this is the public class toPanel, which extends the JPanel. This class involves the class design and implementation of creating a user interface panel with controls for interacting with the canvas. It also encapsulates the UI component and their setup. It abstracting the complexity of UI configurations. For inheritance concept, it inherits from the JPanel to extend its functionality. While this class doesn't involve any polymorphism and interfaces. For the conclusion of our OOP project, the shape drawing program exemplifies the OOP principles, which consist of the modularity, encapsulations, abstraction, inheritance, and polymorphism. Its well-organized design and adherence to this principle establish a foundation for a flexible, extensible, and user-friendly system. The application not only reflects the current state of OOP in software development, but also positions itself for the future advancements and innovations. That's all from our group. Thank you.